Also, here is the lecture number 4. We want to talk about working drawing. In this working drawing, we have the detailed drawing and the assembly drawing. As you can see from the sketches or these drawings here, for the case of detailed drawing, have the parts that have this section has the dimensions. This indicates very clearly the inner part of it, just to give more information about the part or a component. Whereby assembly drawing, it indicates how the parts will form the entire component. For example, this is an engine with the separated parts or disassembled parts. Now they are given to the sequence on how each will be brought to the component to form a complete assembly of a component. So some arrows are provided to indicate which one comes first, or some numbers are provided to indicate the sequential of assembling or bringing the parts together. It can be number 1 followed by number 2, number 3, and number 4, something like that. So this forms the so-called assembly drawing. So the working drawing falls into 2 categories, which is detailed drawing and assembly drawing. For working drawing is a set of drawing used during the work of making a product. In totality, this can be described in this way, that once you refer to the working drawing, is a set of drawing used during the work of making a product. So as we have posted, that working drawing falls into 2 categories, that is detail drawing and assembly drawing. This detailed drawing is a multi-view representation of a single part with the dimensions and notes elaborations to give more clarification for the given part of a component. And when it is for the case of assembly drawing, is a drawing of various parts of a machine or structure assembled in their relative working positions. So we have said that they are given to the sequential on how they are going to be fixed or brought together for the purpose of bringing functionality of the machine or component. So the purpose of doing this. So detailed drawing conveys the information and the instructions for manufacturing of the part. How should it be manufactured? What conditions should be considered? This can be the issue of material used. If it's material and tolerances to be considered, and the material, is it for the where will it be fixed? Assembly drawing conveys the information about completed shape of the product, how it looks like, and overall dimensions, relative position of each part, and functional relationship among various components that form a machine. So this is one example for our universal joint to elaborate the details part of this You can see this universal joint here is a complete component part here, but here is separated and dismantled, indicating these even these screws or bolts are provided to the dimensions. Yeah, even the dimensions are provided for each part. More elaborations are provided here on regarding the holes, even the sectioning to indicate how the interior part of the object is constructed. So you can see it very, very clearly. The inner part of it is provided in terms of section. Yes, this is the hole to the diameter of 0.34. As you can see, how many holes are given there. So let's have for the detailed drawing. Another example is a crane hook. This is a crane hook here, you can see. So here they are dismantled. This crane hook has been dismantled. So each part have the this is the bracket you can see here, and it has been drawn to its full size, and the dimensions are provided on how you can locate the holes here. Yes, and the section is provided for more clarity. How is this part looks like? Yeah, this is a nut, indicating the size of a nut to the two views, that is front and the plan of it. Yeah, so even this is provided to show by the name of each and the material used for each part that form the component crane hook. So this is a detailed drawing. So referring to the title block that are very important to present our drawings, we need to work on this and understand thoroughly the requirement or the components that form the drawing. So we have the name of a company or institution, the title of the drawing, usually part's name that is going to be provided in the drawing sheet number, how many drawings have you performed, and name of the drafter or checker, followed by relative dates of the action. When was it drawn, checked, approved, like something like that, and a revision table. Also unit employed, scale, method of projection, that it can be first angle, third angle projection, which one was employed. Yeah. So the parts of information regarding the object can be, if you refer to the shape, how are you going to present it? It can be orthographic or pictorial drawing. When you refer to the size, you have to indicate the dimensions and tolerance required for the part. What tolerance, if at all, is plus or minus, should be indicated when you are referring to the size of the part of a machine. Also, specifications is very important for when you are drawing the details. Very important to indicate these specifications: part number, name, number required, For example, you are pressing an order of a part that is require replacing to a certain machine. So that's how you can use the parts information to describe for your order. And the type of material is very, very important here. The type of material to be indicated. Which material do you prefer to be used for the designation and the production of the part? And the general notes. For more clarification, you need to include more notes regarding the part that you are pressing an order for the manufacturer or for those who are going to produce it. Also, heat treatment should be given a specification to which will you prefer heat treatment for a part, and followed by the surface finish for your part. Is it coarse? Is it rough? Something like that. And the general tolerance, as you have said, should be indicated. Tolerance for the part to be fixed requires tolerance in order to fit exactly where is required. So, recommended practice. You should draw one part to one sheet of paper, and if not the case, apply enough spacing between the parts. Draw all parts using the same scale. Otherwise, the scale should be clearly shown under each part of the drawing. You have to remember this, that standard parts such as bolts, nuts, and pins do not require detailed drawings. That means something like sectioning is not applied to them. So interpreting detailed drawing is some kind of a detailed drawing. See how if it has been drawn, now you need to interpret it. Yeah, you can see, as we have said, this is the projection. Yeah, so this is, it has been given. Now you need to interpret it to see on how are you going to use it or to produce one from the drawing that has been prepared. So you have the front view followed by the end view to the dimensions provided, as you can see here. You can see here it has been indicated the size, dimensions. So you should be aware on the standards that are applied. What does this mean, which is indicated here? Is it for the diameter? Is it for thickness? How a dimensioning is provided to indicate the thickness, to indicate the center line. So all these should be clearly understood in order to have the capacity to interpret the detailed drawing. One should be aware with the symbols to understand what it means by the provided symbols. For example, this one provided in orthographic views. Orthographic views, as I have said, is for the front, and the other one being the end view, just to facilitate to see the object how looks like So here the dimensions and the tolerance are provided. A surface finish is also indicated that the surface finish is to this standard. And the general notes to give more clarification are provided as well. Even the title block here, who has done this, what material, which date, scale used. So they are all the information are provided in the title block, as you can see down there. Yeah. Now let's see for the types of assembly drawing. We have got the exploded assembly drawing, of which the parts are separately displayed, but they are aligned according to their assembly positions and the sequences. That is exploded assembly drawing. When it comes to general assembly drawing, all parts are drawn in their working position. Working position. You have to note this. This exploded assembly refers to the parts being separately displayed, but they are aligned. They are aligned according to their assembly. Which one comes first and which one follows after being fixed to the motherboard. So you can see here, when it is general assembly drawing, all parts are drawn in their working. How are they working together? The third is detailed assembly drawing. All parts are drawn in their working position with the completed dimensions. Detailed drawing. Let's see for the exploded assembly. You can see here pictorial representation and the finished product. This is a drawing table. Have a look. So they have been arranged, all the parts that form this drawing table, and how they are provided in the exploded assembly. They are arranged or they are placed on how they are going to be fixed. You can see even the nuts here and the holes to be fixed. This is the part that will be on the floor, and this is part of the stand on how they, and this one is for varying the height. Here you can see. So they are arranged in a sequential way, in such that it becomes easier for one to fix it by following the sequence here. You can easily fix it to get a complete product by following this sequence of arrangement that is provided in the pictorial representation. This is a full component, as you can see here. So you are given this and the complete one. So when you have pressed an order and you have these things have been brought in a box, but you are given this drawing which will aid you on arranging and coming up to a complete product which looks like this. So this one is to help you to end up on a complete part. When it is general assembly, that is pictorial plus the orthographic. This component in pictorial is given even to a section to indicate how it looks like for the inner part. You can see a bolt that is connecting the two parts here being fixed together, and the shaft inside, how it looks like when it is fixed to the component. And here is provided the numbers, how they are fixed, arrangement of in the orthographic, how they are arranged in the orthographic, how they look like, being maybe this is the front part of it, And this is in orthographic, indicating the interior part of it. So a section is provided. You can see some hatching lines here are provided to indicate that they differ. This hatching lines lies to the right hand side, while this one another is lying to the other direction. So you can differentiate that this part 1, part 2 that form this component. As you can see here. So being fixed to this component, even the numbers are provided to indicate how will be fixed to the entire component. Yeah, another example is here. This is the component that is going to be fixed there. So little portion of it has been sectioned to indicate how it looks like for the inner part of it. As you have said, some numbers are provided, and clarification for regions here is given just to see which number and which is the name for the specific number. For example, 7 is a spindle handle. 7 spindle handle here. Yes, so to go. So regarding the title block, how are you going to place this information? Or assembled parts should be placed this part of your sheet, followed by general notes here, and here is the type of projection, and here is the title block here. So that's how one can give the information and part of the list here, regent. That's assembled and title block, they are put together, as you can see here, assembled and title block. So this has been assembled. Those parts that were separated, now they are brought to bring a complete component here, and the numbers are provided here. Move up jaw, that's number 1. Move up jaw. Here you can see the arrow here. Move up jaw. Move this direction. So easy. Given the name here and the number. So for the case of section line practice, do not draw section lines on section view of standard parts. We have already expressed this, that threaded fastener, washer, longitudinal cut, or for solid shaft, pins, key, longitudinal shaft are not included in sectioning. So interpreting assembly drawing, assembling steps, function of each part in a machine, design concept. When you interpret the assembly drawing, you have to bear in mind the assembling steps. What are the assembling steps to follow? Function of each part in the machine, and design concept should also be considered. Let's start with the shaft support on a machine housing. Let's see the functions of main parts. Yeah, I've got the functions of main part here. For each particular part, I've got its functions here. When you want to discuss about this machine, for example, bearing support the rotating shaft. We have got a bearing here. It's a bearing being sectioned to indicate the inner part of the bearing. It supports the shaft that is rotating from the housing. You see the housing. So support the rotating shaft to rotate freely. Also cover, this is the cover, control an actual movement, just to keep the movement to be steady and without moving. It still has to continue rotating without moving from the axis. Also prevent the bearing unit from rotation. The bearing has to support the rotating shaft. For designation concept, you have to avoid direct contact between rotating shaft and housing, as well as cover plate by using a bearing and a clearance hole. This concept should be borne in mind when you are designing such kind of a component, that must ensure that there is no direct contact between the rotating shaft by employing some washers and ply nut, just to ensure there is no direct contact with the housing that form for a component from a rotating shaft. Followed by assembling steps. How are you going to assemble this? You have to follow the sequence, which one comes first and which follows. When dismantling a complete component, it is advised that you can label which one was the first to be taken out or tightening. So you have to note, you have to number with the sequence, which will be easier for you on assembling the parts. So insert the part on the tapered end of the shaft, yes, followed by insert the washer, non-standard washer, then tightening the nut. It should be taken into consideration which one comes first and which one is to follow. For the purpose of function, washer functionability of which improve the distribution, the tightening force on the part, allows the means of tightening here. This is the washer that we are referring to, and this is our nut. When you tighten it, if there is a nut here, improves the tightening of this shaft. Design concept. So the length of the tapered portion and the depth of the tapered hole require calculations. So these should be considered. What is the length for the tapered part? Think about it. Consider for your designation. And they have to be, it shouldn't be very, very long unnecessarily. So you have to think of it before coming to production. Assembling steps to be followed. As you can see, this is the spring free in free length before being inserted to the given place for it functioning. It is to this length. How are you going to insert it here? And how will it be possible for it to be fixed? It requires procedures, which one to be done first. So insert the spring into the casing first, as you have already taken out this one, which is worn, and you want to replace it. So you have opened the cap. So then followed by tightening the rod, the spring loader up there. Close the cap and tighten. So procedures are very, very important to follow here in order to fix this. Otherwise, you can see this appears to be very long in comparison to the one that is already fixed here. But you have to open up the cap, and then you can get a space to insert, followed by tightening the rod to the spring loader, then close the cap and tighten it back. So there are some points to be considered regarding the surface finishing and tolerance, size and the geometry. With the surface finish is very, very important for the case of customers, to attract the market, to convince the customer. So you have to think of it referring to the surface finish. If it is of good standard, good to appearing, it's appealing to eyes, it can attract customers, it becomes easier now for the market. And when it comes to tolerance, you have to think about the size and the geometry which will allow replacing the worn out material, and it should be standard in order to allow this to fix the product to be easily fixed to the place where is required. So the two should be borne in mind when you are producing a product for as a spare part. So surface finishing means the quality of a surface. It relates to the level of roughness of a surface. The purpose, we want to control the accuracy in the positioning and tightness between the mating parts. So if it is very rough, it can be very difficult for it to be fixed. So to reduce the friction, especially for the part moves relative to the other parts. So there is a significance of having a reliable surface finish for the part. To control the accuracy in the positioning and the tightness between the mating parts, they can lie very exactly, they can fit exactly, or you can reduce the friction, especially for the part moves relative to the other part. Tolerance. Tolerance is the total amount dimension, may vary. It is defined as the difference between the upper and the lower part. Purpose of this, to control interchangeability of the parts, to ensure the mating parts will have a desired fit. Thank you for watching this. See you next time.